Hello students, let's try to understand a problem that is asked by Nitya. What is the problem, student? Draw the structure of, they are saying all the isomers. Here we have to draw the structure of all the isomeric alcohol molecular formula C5H12O. See, this is asking only alcohol, so we need not to understand about ethers. Okay. Now, classify the isomers of alcohol in the question 11.3. This is 11.3, H primary, secondary and tertiary alcohol. So this is very simple, student. If you see this question, this is what C5H12 and this is the O. So this is the alcohol, 5 carbon alcohol. So how to go about? Okay, so case 1, if you see, student, case 1, so 5 carbon, you can go 5 carbon chain, 5 carbon chain. This is what the first approach we will go. Then if case 2, student, we will go, that is after 5 carbon chain you can go 4 carbon chain, 4 carbon chain, and finally, student, you need to go 3 carbon chain. This we have to go 3 carbon chain. Now, students, what we can do, if I will go 5 carbon chain, let us try to go with the 5 carbon chain. CH3, CH2, then again CH2, here is the CH2, CH2, and this is the OH. If you count the name of this one, student, we can go here, you see. So this is the 1, here is the 2, this is 3, here is the 4, this is the 5. So what will be there, student? Pent. This is pent. Single bond is in 1 all. Now this 5 carbon chain, let it be, and just shift the OH group, student. So you will be able to, because since if you see here the very profound way of doing, see this carbon is the A if you are considering, so this will be B, this will be C. Similarly, if you are talking, if OH group is this side, so it will be A and this is B. So total different type of carbon are how many are there? A, B, C, 3. So here it will be how many, student? This will be 3. Okay, in this case, student, in this case, if I will go, so here is with what? CH3, here will be CH, here is CH3. We have to see that is how many different kind of the carbon are there, CH2OH. So suppose this is the A, so this is the B, okay, here is C, right, and this is going to be what, student? That is, this will be also D and this is also D. Okay, so total type of carbon is how many? 4 types are there, so 4 isomers is possible here, 3, 4, and here is for the 3 carbon chain, if you see here 3 carbon chain, this is, so here will be CH3, this is again CH3, this is CH3, here is CH2, and this is, so you will find this is also A, this is A, this is A, all are the A type, this is also A type. So total isomers here possible will be what, student? That is only 1, right, student? So total isomers will be the 8, that you need to understand, because we have to find out that how many types of carbon are there. You have to check the environment. So here it is the A, this is the B, different carbon, because OH can be here, this is also OH can be here. So 3 different possibilities are there where you can place the. Now in this case there is also different possibilities. You can move on this CH3 group. So A, B, C and D, 3 different type of the C is there. So the 4 different types. So it will be the 4 isomers, here 3 isomers, here only 1 is there. Either you can go here, because if you are attaching this OH group this position, so it will be CH2OH, CH2OH, so all are the identical, so isomer will be 8. So here will be what, 3 plus 4 plus 1, so it will be how much? That is 8. So let us draw. First I already dot. Now for 5 carbon we are going now, for 5 carbon, so here you see the 1 is already open. Now OH group I am putting on the second position, so CH3, student, CH2, here is again CH2, then here will be CH, this is the OH, and this is the CH3. Now numbered it 1 2 3, this is the 4, here is the 5. Student, what you can do here, in this case, if I will ask you, so you will find that while naming, so it will be that is pent, single bond is there in 2 all. So first one is pentane 1 all, and that is pentane 2 all. Now let us see the next one, what possibilities is there. OH group can be on the third position, so it is the CH3, this is the CH2, then you can go CH, here will be the OH, then finally it is the CH2 and CH3. So you can number it, student, 1 2 3, this is the 4, and here is 5. So what is there, student? Pent, single bond in 3 all. So they what is the degree, student? This is the 1 degree primary, right? Because alpha carbon is attached with 1 more carbon. Here is, you can see, this is the 2 degree, student. Why it is 2 degree? Because this is the alpha carbon attached with 2 more carbon, and this is also going to be 2 degree, student, alpha carbon attached with the 2 more carbon. Now please go with the 4 carbon chain, student, 4 carbon chain. So 4 carbon chain, this is the already 1 degree I made already, student. This is how can you number it? 1, this is the 2 3 and 4. How we will name it, student? So it will be 3 methyl, student, 3 methyl butane, 3 methyl butane 1 all. What is the degree, student? 1 degree. Okay, this the degree of alcohol will be 1 degree, right? Now move on the next one. So CH3 group can be placed this position also. So let us move place this CH3 group. So here is CH3, this is the CH2, then CH, here will be the CH3, student, this is CH3, then here will be the CH2, and this is the OH. So you can name it 1 2 3 and 4, right? So it will be that is 2 methyl butane. What the position will be there? Butane 1 all. Now student, one more thing you can place. OH group you can place. OH group you can segregate. So this is what is the degree? This is also 1 degree, because alpha carbon is directly attached with 1 carbon. Now see the OH group. Now I am trying to move. 4 carbon is as it is, student. Keep in mind. So CH3, let it be CH2. Here is CH, student, CH. Now here is the CH3, student. This position OH, and here is it will be the CH3. So see, here you can count 1 2 3 4. What will be the name here, student? It will be the 2 methyl, and that is butane, 2 methyl butane 2 all. One more possibilities is there, student. What the possibilities? Here you see, student, CH3 CH, here you can put the CH3. Then what is the degree of this one, student? Its degree will be 3 degree, because alpha carbon attached with 3 carbon. And here is the CH, then here is the OH. Again you will find, student, that is 1 2 3 total parent chain is the 4 carbon chain, and 1 side chain are there. So it will be 3 methyl, if you are naming 3 methyl butane 2 all, If you are placing this OH group third position and this side, but the compound will be same. Now let us move on the other one, the last one, student, where we are going to have the 3 carbon. Okay, so in this case, student, already I made, student, you can see this compound. Okay, wherever you try to put the OH group, it will be always the same compound, whether this OH group you are putting on this carbon A, all are the same, student, identical. So what is the name, student? 1, this is the 2, this is the 3, So 3 carbon, so 2 comma 2, this is the dimethyl student, 2 comma 2 dimethyl propane, propane 1 all. So what is the degree? 1 degree student, keep in mind. So total is how much student? 5 carbon chain isomers is 3, 4 carbon chain isomers is how much student? That is 4. So 3 4 7 and 3 carbon chain will be 3 carbon isomers will be 1. So total isomers you are going to get student 8. So it's very simple. Thank you so much for watching students.